Okay, 6.4, polyatomic ions. What is that? Well, polyatomic means, poly means many, right? And atomic atoms. And we know that ions are groups with charge. So this is an ion made up of more than one atom. And in this example, chlorite is a polyatomic ion. Sodium is just our regular Na+. One thing I want you to take note of, as I always tell people, is if you see a T in an anion name, or even, an anion name, it's going to be a polyatomic ion. Because remember, in the last video, we learned that chloride is this. Well, chlorite is something else. It's a polyatomic ion. We're going to go over those now. And also, before I forget, turn over your periodic table, and if you look on the back, there is a list of common polyatomic ions on the top right. So you will have this piece of paper for your exams. I always encourage people to memorize some polyatomic ions, and you will have a quiz with limited times to encourage you to have it with automaticity. But you will have that table for exams. And the reason that I encourage you to memorize the polyatomic ions is because you need to take that out of your, the forefront of your thinking when solving a problem. It shouldn't be a step in solving a problem. It should just come to you quickly. And if it doesn't, it will make many problems more complicated to solve. Okay, so just as I said, they're a group of atoms that move around together to form a charge, and the charges are usually -1, -2, or -3. There is one positively charged polyatomic ion, and that is ammonium. And just so you have it next to you, or right next to each other, ammonia and ammonium are not the same thing. Ammonium is NH4+, ammonia is NH3. Ammonia is a molecular compound, ammonium is a polyatomic ion. Okay, so many products contain polyatomic ions. Okay, so unfortunately when I import into Notability, a lot of these formulas don't come through, but I'll fill out some of them. So they're listing the common nonmetal and then the common polyatomic ion. So the one with hydrogen is OH-, that is hydroxide. We just saw ammonium. Also important for the nitrogen containing polyatomics is NO3-, which is nitrate. And nitrite is NO2-. Among the chlorine ones, there's perchlorate, which is ClO4-. Chlorate, which is ClO3-. Chlorite, ClO2-, and hypochlorite, ClO-. And then there's ones with carbon, carbonate, CO3-2-, hydrogen carbonate, CO3-1-, cyanide, Cn-1, and acetate, C2H3O2-. And I would say among these, undo. The important ones are hydroxide, actually those. Actually I wouldn't say any of the chlorates are particularly important, but definitely carbonate and bicarbonate, acetate for sure, and cyanide's a good one to know. There's some other ones. Sulfate, SO4-2-, hydrogen sulfate, SO4-1-, also called bisulfate. sulfite, which is SO3 2 minus, and hydrogen sulfite, HSO3 1 minus. Phosphorus, PO4 3 minus, hydrogen phosphate or biphosphate, HPO4 2 minus, dihydrogen, PO4 1 minus, and phosphite, PO3 3 minus. Oops, hold on. 3 minus. On this page, the ones that you want to know are sulfate and phosphate. So the most common ones generally have an ending of ATE, SO4 2 minus, PO4 3 minus, NO3 minus 1, or 1 minus. Now, one thing that's really going to help you is that if you can remember all of the 8 polyatomic ions, if you take away one oxygen and keep the same charge, you have the sulfite, the ite version of that polyatomic ion. So if I were to take sulfate and remove one oxygen and keep the same charge, that becomes sulfite. Phosphite would be PO3 3 minus, and nitrite would be NO2 1 minus. Then there's cyanide and hydroxide. I don't know what rule they're talking about. Those don't have oxygens. So let's, and another helpful clue is that if you add an H plus, then the charge changes. You're adding a hydrogen. So, for example, carbonate is CO3 2 minus. Well, if I add an H plus in front of it, it becomes bicarbonate or hydrogen carbonate. But because I'm adding a +1, my overall charge decreases. It becomes more positive. So instead of being -2, it's -1. So bicarbonate is HCO3 minus 1. Sulfate is SO4 2 minus. Bisulfate would be HSO4 1 minus. Okay, so halogens form 4 polyatomic ions with oxygen. These are the only ones I've heard of. Perchlorate, which is pretty nasty, is ClO4 minus 1. Chlorate, ClO3 minus 1. Chlorite, ClO2 minus 1. And hypo means also one less oxygen, ClO minus 1. So notice we have per, we have ate, we have ite, and we have hypo. And when I'm trying to remember things, I start with the 8. If you add a per in front of it, you get an extra oxygen. When you go from 8 to ite, you lose an oxygen. And when you go from hite to hypoite, then you lose 2 oxygens. But notice the charge is the same, -1 for all of them. Okay, the rules for writing formulas with polyatomic ions are the same as with ionic compounds. You always do the positive ion first and the negative ion second, and you still have to balance charges. So if someone says, I have magnesium nitrate, what is the chemical formula? You're going to say, well, I know that magnesium, because it's in group 2A, is magnesium 2 plus. And nitrate, because I've memorized the formula, or I've looked on the back sheet, is NO3 minus 1. Well, I have +2 and I have -1. So I need more negative charge. I need 2 of those nitrates. And so my formula is going to be magnesium. And then when you have more than one polyatomic ion, you have to put parentheses around it. So this 2 means that there's 2 NO3s. And if I were to write out the number of atoms in this, it would be 1 magnesium, 2 nitrogens, and 6 oxygens. Okay, so write the formula for aluminum bicarbonate. Oops, here it is. Okay, so let's break it apart. Let's look at the ions. Aluminum is 3 plus because it's in group 5A, and bicarbonate is HCO3 minus 1. So this is plus 3, so I need a minus 3. And since those are minus 1 each, I need 3 of them. So it will be Al, and again, because it is a polyatomic ion, I have to put parentheses, 3. Okay, write the formula for sodium phosphate. Our cation is Na plus, our anion is PO4 3 minus. So that is going to be Na3PO4. Okay, naming ionic compounds containing polyatomic ions. Same thing, it's positive ion name followed by positive ion name or cation name followed by anion name. If that anion or cation turns out to be a polyatomic ion, we already know the name. So if we look at this guy, we know that that is sodium, and you want to be able to recognize that as sulfate, so it's sodium sulfate. Okay, now I have, this part is actually probably most tricky, because now I have a transition element and a polyatomic ion. So iron could be plus 2 or plus 3. So the way I would approach this is I would say, okay, let me, I'm going to add a page here. FePO4. Okay. Then what is the name? Okay, so right away I go, okay, PO4 is 3 minus. And that means that my anion total charge is minus 3. My cation total charge is plus 3, and I only have 1. So that means that this iron has to be iron 3. And so the cation name for iron 3 phosphate. Okay, the next one is aluminum. Oops. This is where I see a formula and it's like a language. I say the name without thinking about it. Okay, so what is this? This is that cation, because we know that because aluminum is in group 5A, and all of those are 3A, sorry, group 3A, and all those in that group have a 3 plus charge. Carbonate is CO3 2 minus. And so this cation name is aluminum. This anion name is the name of the polyatomic ion, and that's carbonate. So this will be aluminum carbonate. And so here's a table just listing some common compounds with with polyatomic ions and what their use is. Aluminum phosphate will be that. Aluminum sulfate. Barium sulfate is a contrast medium for X-rays. Calcium carbonate is an antacid. Aluminum sulfate's for antiperspirant. So all of these are written down. So I would say you have all the formulas on Dropbox on this slide. You want to be able to come up with the formula for each of these, and you can check them there. Okay. Okay. Copper 2 nitrate. And iron 3 hydroxide. Tin 4 hydroxide. Okay, so let's do the formula. So aluminum is going to be Al3 plus, nitrate is NO3 minus 1. So we're going to need 3 nitrates, Al, NO3, 3. Copper 2 nitrate, that's copper 2 plus, and nitrate is NO3 minus. So we're going to need 2 copper nitrate, 2 nitrates. So CuNO3, 2. Iron 3 means it's iron with a 3 plus charge. Hydroxide is minus 1. So it will be tin plus 4, OH is minus 1. Come together, that will be SnOH4. Okay, I'm going to stop.